Hello and good afternoon, everyone. Welcome to another live session at the Reactors. My name is Rav and I'm the Program Manager at Reactor London. Before we get into the session, please take a moment to read our Code of Conduct. We're all here to learn, so please be respectful of other people's views, understanding of differences, and please be kind and considerate in the way you engage. The chat will be open throughout and we do encourage you all to participate. Today's session is on guaranteeing application and Azure security with Devsecops, and it will be led by John, who is an MVP, Microsoft MVP. And with that, I'm now going to bring up John on the screen, and he will then continue the session. Hi, John.
Hi, great to be here. Thank you.
It's all yours. So if you share your screen now, then I can bring it up.
Okay.
Okay. All yours. So I'll be in the background if you need me. Just shout my name.
Okay. Great to be here today. You should see a slide saying guaranteeing application Azure security with Devsecops. My name is John Staveley, MVP. I'm based in Leeds in the north of England. I'm an IT contractor by trade, and you can contact me on LinkedIn or Twitter on one of those addresses. So what we're going to be talking about today, we're talking about Devsecops, the security part of DevOps, and Paul left security. So I'm going to assume you know a bit about security and application security specifically to begin with. And we're talking about amplifying the security and getting that security information back to the developer as soon as possible, whilst they're typing or as part of the build chain. And we're going into great detail about some of the tools you can use in order to enable that. We're going to be talking about how we can enhance our overall security baseline and use secure by default, and then use reproducible security-focused deployments using Azure DevOps as our build pipeline with Azure Pipelines and ARM templates to set up the resources and infrastructure. We're going to be looking at a lot of different tooling we can use for that, looking at a bit of lightweight threat modeling and where that fits in our process, some of the integrated development environment checks, so as we're coding, what security information we can get there, and then perform some static analysis, both locally and on as part of the build chain, that will analyze our code platform, component choice, and enforce security unit tests. And then do a bit of dynamic analysis using OWASP and security acceptance test. So all of these help build up our picture of our security profile of our application and perform different functions and gain different information. So there is no silver bullet here. They all provide value at different stages. So at the end, I'll provide the code that comes along with this presentation and slides on SlideShare. There used to be a lot of demos with this, but because we're quite limited in time, we'll have to skip over some of the demos as we go through. So why security? Well, with GDPR, the fines are getting ever bigger, and our big organizations are losing a huge amount of money every year, and it just keeps getting worse and worse. So anything we can do as developers to bring security into our environments and feed that back to management and get these issues solved before they get out into production is a great win for the organizations we work for. So DevSecOps, just DevOps with a bit of a focus on security. So we'd expect a fast flow of work from Dev to Ops and a fast flow of feedback. So as you're typing, as you're performing static analysis on the server, it's then feeding that back to the developer, potentially failing the build, but more just providing information so they can become better security developers and focus on our improvement of daily security work. And of course, we want to work with as many secure by defaults as we can, both in our code and on the platform. So as in this, I'll provide a code base that has a platform in Azure that it sits on and the code that runs in that. And we're looking at how we can secure both of those things at the same time through our build chain. We want to pull it earlier. left in the development cycle. So a waterfall process typically looks like requirements analysis, design, coding, testing, hardening, and production. And then you think about maybe doing a pen test. But really, what we want is security in the requirements phase, security in design phase, security in the coding phase of every feature that we're delivering, not just at the end of a sprint or maybe after 6 months. What this means for our organizations and for us is that secure defaults means there are fewer security defects going into production. Why make the mistakes that others have made before when we can sort those out and get the tests that prove we're using secure defaults? We can reduce the average time to detect a security issue, and automation allows deployment of security updates quicker. So we know that there's an issue before it gets exploited. And research has shown that it provides a moving target to hackers. So by being able to move forward quickly and change your security profile or organization continuously, it's much harder for an attacker to exploit our system. And of course, there's the cost issue where fixing in production is 6 times more expensive than fixing at design. Let's fix it as early as possible. So what we're going to secure, so a long time ago, I created an application, a project called the Security Essentials Project. It had your typical application security, OWASP top 10, defeats cross-site scripting, cross-site request forgeries, had secure headers, enforces SSL, and all of these kind of useful things for application security. So it looks like this. So you've got either your user or an agent, an attacker coming in from the World Wide Web. Is protected by a Cloudflare firewall, which behind that sits an app service. And then from the app service, you're protecting your secrets using Key Vault. It's got a SQL Azure database and blob storage behind that. So that's broadly speaking the platform that we're using, Cloudflare plus Azure. And there's an application that sits in the app service. You can have a look at all the code here, as well as the code for the application with all those security defaults on. It is a .NET framework project, so it's not .NET Core, but I needed something I could test, and it was a good platform for that. It also has the infrastructure of code. It has an Azure Pipelines YAML file that sets up the infrastructure as code. It deploys the environment using an ARM template. It has PowerShell scripts that set up Cloudflare, which enforces TLS, HTTP2, enables the WAF, protects against denial of service, SQL injection, and many others. And then it locks the Azure App Service down to Cloudflare, so the App Service can only receive instructions from Cloudflare. It has Key Vault to protect secrets, virtual network access to secure access to assets like blob storage, and then it sets defaults for each of these assets. So for blob storage, it enforces encryption at rest and then transit, and then it's firewall to the virtual network. For SQL Azure, enforces transparent security defection. So we're using as many secure by default as possible. So in Azure Pipelines, it looks like this. So you've got your YAML file. Oh my goodness, it's going to cause me some pain. One moment, please wait. Okay, so this is the YAML file. So it's built into stages. So build and run unit tests. And it's got various security tasks here. Sonar Cloud and NuGet installer, the build, run the unit tests, including the security unit tests. And then it goes on great lengths to do all the different security tests. But that's broadly speaking what it does. So we have a set of variables here. And what I find a useful approach is you have to store your secrets somewhere, and you don't want them in plain text. So I find Azure DevOps variables is a really good place to keep those. So here, the Cloudflare user service key is encrypted. You may then use a build step to deploy that into either a transform file or key vault, but this is the kind of like my starting point for secure assets. You can browse the marketplace. So a lot of these build steps use extensions here. So if you do a quick search on security, I can add in, for instance, the SNCC security scan into that build pipeline just by clicking on that, and then I can use it in that Azure Pipelines. So why automate? So we've seen the Azure Pipelines YAML file. I would say it's easy to create new environments. So if you create a UAT environment or a pen test environment, it's easy to just parameterize that. And it's easy to roll forward, so you can fix issues, particularly security issues, very quickly. So how do you see CI/CD? That's the heart of security. So it enforces the rules, it enforces the security checks, it audits any build steps you've taken and security checks you've taken. So it becomes a much more central part of your security strategy and enforces all of the security rules as you're going forward. Okay, so Azure Pipelines is broadly broken down into these steps here. So we have security unit tests, code analysis, static analysis, component analysis, what NuGet packages you're using and whether there's any known vulnerabilities into them. Checks the platform, the Azure template that we're using to make sure you're using secure defaults, and then lots of other checks which we'll be going into later on. So it publishes artifacts here, sets up the platform as a service in Azure, sets up the firewall in Cloudflare, it deploys the build to an integration server, and then runs these acceptance tests for security, and then does dynamic analysis. So it does a full end-to-end view of how secure your environment is. Oops. So how are we going to pull security left? So broadly speaking, I use this approach here. We've got the Devsecops approach is cut down into these phases: pre-commit, source code. You commit in source code, then you do continuous integration and build. That creates binaries, which are then deployed into an environment. You do acceptance tests, which then get deployed into production, and then you get feedback in production. So all of these are different checks for security you can do at each of those stages. So at the design phase, you can do threat modeling and IDE checks. The CI phase, you can do software component analysis, static analysis, security unit tests, and we'll be going through all of these in some detail as we go through the presentation. So first of all, we're going to look at the pre-commit stage. So this is when you're in your IDE, tapping away and creating code and features. So first up, we're going to look at lightweight threat modeling. When the code is the design, where and how do you catch security problems in the design? This is where threat modeling, and I mean lightweight threat modeling, not conforming a committee together to pontificate about what's secure and what's not secure. I'm going to talk to you about a very straightforward approach that you can use tomorrow when you're designing your applications. Broadly speaking, threats can be categorized in using the STRIDE methodology: spoofing, pretending to be someone or something or not, for instance, a cross-site request forgery; tampering, sniffing or changing something at rest, in memory, or in transit, something like SQL injection; repudiation, doing something and then denying you did it, and if nothing's logged, then you can't prove that someone did something; information disclosure, giving away headers or giving away information to, like in a man-in-the-middle attack; a denial of service that can be prevented by using Cloudflare, or, for instance, locking out accounts; or an elevation of privilege, doing something you're not authorized to do, i.e. via an indirect object reference, or having super user privileges when you should just be a standard user. So for this, I use the Microsoft Threat Modeling tool, which is still in preview, and it has a built-in Azure template. So all of the stuff you'd find in Azure it has security references for in that template and provides really valuable security information that you need to think about. Okay, so here's my application set up. So you've got simulated here a browser with a user in front of it, my Cloudflare firewall, the Azure App Service, which then talks to an Azure SQL database, an Azure Key Vault, and a blob storage. Between each of these, I've dragged these interactions. So, for instance, the Cloudflare firewall communicates with the app service via this HTTPS service. So this process occurs when you're thinking about changing something in the infrastructure that might have an impact in your security profile. And you just drag and drop these items here onto the canvas, and then it sets it up for you. So once you've set up your environment like this, it breaks down those interactions in this threat list here. So it's saying here, an adversary can fingerprint an Azure web application or API by leveraging server header information. This is the category of information disclosure. It happens over HTTPS, and this talks about the possible mitigations. So here, remove standard headers, and I've said, well, this is mitigated because the server headers have been removed by the code, which you can have a look at on GitHub. So I'd say, yes, that is a threat, but I've done mitigations against it. So here's another information disclosure. An adversary can read confidential data due to weak connection string configuration. And this is the interaction between the Azure App Service and the SQL database. And here is some more information. And it provides these useful links here, which you can then go to read up more information. But this is the long and short of it. Clients collecting Azure database using collection strings should ensure encrypt equals true and trust server equals false. So I've said this is mitigated because I've applied what it's suggested. Now let's say I'm a developer and I'm doing CV-driven development or something like that. And I go, oh, Azure Redis Cache. That's really cool. I'm going to use that in my application. Now, I've never used Azure Redis Cache before, so I don't know anything about how to secure it. So what I can do is just drag this interaction here and say, well, my Azure App Service is going to talk to my Azure Redis Cache. Now, when I click Analysis View again, this will have created some new interactions here. An adversary can gain unauthorized access to resources and Azure subscription. And it's highlighting that request I've just got there. And it then says, enable fine-grained access management using RBAC. And that's what I have to do to secure it. So going from knowing nothing about it, it's given me some really useful security information to help me secure my application. And I haven't had to get a committee together or read up lots of documentation. All I'm doing is dragging objects onto a form, and I'm getting security best practice. There's lots of links throughout the presentation, but I'll be sharing the link to the presentation afterwards so you can grab all of this stuff. Okay, so now we're going to checks the IDE. So you've got your code and you want to make sure that you're using the best security rules you can. Now, IDE checks can help spot some basic security errors like SQL injection or weak cryptography. A good IDE check must all have IDE integration, obviously, but better than that, one should also run in Azure DevOps. So if I ignore something in my IDE, I can potentially get Azure DevOps to fail my build and get me to go back and resubmit that with better security. It should allow building of my own rules, have a low false positive rate, and having a way to define exclusions. So even if it's a false positive, I can just silence that rule forever and give access to code rules and links to securities to help me become a better secure coder. So lots of different IDE checks. DevSkim can help find insecure hash encryption algorithms, insecure URLs, and storing security credentials in code. Unfortunately, that's only for VS 2019. Scan offers free and pro versions, checks for secrets, and checks compiler settings and auth settings. VeraCode you need an account to run for, and checks for SQL injection. Snyk I've only just got access to, so I don't need a lot about that, but I know that's popular in the industry. And there's also continuous delivery tools for Visual Studio. So this is my Security Essentials code here. So let's say that I fancy using SHA-1 today, which is obviously a deprecated and very insecure hashing standard. What I would expect to see is this rule here, which says CA 5350 constructor uses a weak cryptographic algorithm SHA-1. So I'm getting that feedback as a developer as I'm going along. And the same with MD5, it should be using MD5. Yeah, broken cryptographic algorithm. Now, maybe you're using it for just to check that two files are the same. So what you need is a way to suppress it if that's what you're doing with it, rather than securing something. So I can hit in suppression there, which will put in that suppression for me. So we've designed our infrastructure, we've committed our code, and it's in the source repo here. And now we're in the build server, and this is where we can do this kind of testing: SAST testing, static application and security testing, software component analysis, and security unit tests. So I'll be going through each of those in turn. So for SAST, there's a number of tests you can use. You can use FXCOP, which I'll be going through, and you can also do Scan and Roslyn checks. You can use Sonar Cloud, which is SonarQube as a service. You can do Microsoft Security Code Analysis, which has a number of components at the SAST level, which are Credential Scanner, checking for credentials, Roslyn Analyzers, which are some of the IDE checks you've seen, and also TSLint for checking TypeScript. And then finally, there's the AZSK ARM template checker for testing you've set up secure defaults in ARM correctly. So firstly, FXCOP, it can check security, obviously, but also code quality, design flaws, globalization rules, naming, performance, maintainability, portability, and reliability. In terms of security rules, it can catch insecure SQL, check for secure class design, check for insecure XML and data type definitions, anti-forgery checks missing, weak cryptography, use of deprecated security protocols, weak cause, and lots more. So you install the package through NuGet, through FXCOP analyzers. And I know that you should choose the version that matches your build agent in Azure DevOps. Otherwise, you'll just have a load of errors and it won't work correctly. So once I've installed the package here, as you can see, this is my packages folder, and I've got all of these rule sets. Now, what I've done is I've grabbed the security rule set and then dragged it across to here. If you have a look at the rule set, it's just an XML file. As you can see, I've got do not use weak cryptographic algorithms highlighted here, where the action is warning. It's say it's just an XML file, but if I click on that, I get a bit more formatting. And here I've as you see, there's quite a lot of checks there. I'm going to focus in on this particular rule here. Do not use weak cryptographic algorithms. Now, in my previous example, I've put in this weak cryptographic algorithm, and if I click build, it should give me a nice error message, a warning rather, because it's set to warning. Okay. CA. I'm going to have to 5350. Okay, it didn't give me a warning. What was wrong with that? Maybe it's this rule. I'm just going to set that to error. So if I include a weak cryptographic algorithm, it's going to build again. As you can see, it's now failed the build. Usually it tells you why. Okay. Okay, that's not quite worked. Yes, okay, error, CA535. I don't know why it's not showing up in the error list, but it has failed it because I'm using a weak cryptographic algorithm there. So what does that mean? So, I mean, normally you get the green squigglies if you've done some poor coding, but what this means is it'll actually fail it on the build server as well. And that's the key difference here. Okay, so next up is SonarQube as a service. So this has reached sonarcloud.io. It can show you what's wrong and how to put it right. It can show you what security vulnerabilities you got in your code, of course, highlight bugs, invalid CSS, deprecated HTML, performance issues, code duplication, etc. But we're interested in the security part of that. It is free for open source projects. So my Security Essentials project is open source, so I can show you license free, and analyzes where bugs are clustered and can fail the build. Okay, so here's the Security Essentials project, and it can show you the error rate over time, code quality, gates in this nice graphical interface. You need to set it up using your predefined key and project name, and then analyze the code and create a report. So here it says, well, I've got 2 reliability bugs, no security bugs. Wonderful. Probably mostly because I'd fixed them, because I ran around this first time I did have quite a few. But if I did have a security bug, like I did when I first ran it, it would, for instance, this open redirect vulnerability, it's saying, well, the entry point is logon async, where I've got this return URL. The return URL is here, and you need to check that it's not, the return URL is actually to your application and not a third-party application. So it gives you links and examples of code you can look at to fix that vulnerability, which is pretty handy. So next up, in terms of static analysis testing, is the Microsoft CA Credential Scanner. It can detect, the Credential Scanner can detect credentials, secrets, certificates, and other sensitive content in your source code and your build output, because as we all know, putting secrets in your code is a no-no, and includes 25 different searches supporting 70+ file types. So what you get as a build artifact is something that looks like this. Just an XML file saying that there is a secret in file, and then provides a description of it. So in my web.live.config, it's saying there's a secret in file, and it's found a password, symmetric key, or storage credential. So you can provide it just as a warning or get it to fail the build as it suits you. So MCSA comes with a lot of other checks. TS-lint, which checks TypeScript for readability, maintainability. It checks you've not used eval or banned terms or string-based timeouts, and you've enforced use strict. It also got Roslyn analyzes, so security tests you're running in the ID can also be run on the server. And it produces a nice report you can use to break the build if required. You need Unified Support Advanced tier. I don't know what that is, but apparently you can buy that as an organization, which is $5,000 per Azure DevOps organization. But that covers you for all of the projects. So if you've got one project or 1,000 projects, it's just one flat fee. So you can run all of these checks. So next up is the AZSK, the Azure Secure Kit, which can run security checks against your resource group, ARM template, subscription, and provide continuous insurance and monitoring and telemetry. I've only really used the ARM template in Anger, and it is constantly updated. Even if it is marked deprecated, there is something called AZTS, which is meant to have superseded this, but in my view, they perform different operations, and I'll go into that in a moment. And there's a link to it. So you can do resource group and ARM template checks. It can be run locally or in Azure DevOps. It's just a PowerShell script. And then there's a build task that can also fail the build in Azure DevOps. So the kind of checks it can do, for instance, for an app service, if you've seen an ARM template before, it's basically a JSON file with a load of settings in it, and in there will be a setting that says HTTPS only true. Now, if you haven't said that, it'll then provide a file which can, again, be used to fail the build that says you haven't enforced HTTPS. You can also check for HTTP2. You've got RBAC configured. You've correctly set SSL bindings, WebSockets disabled, FTP disabled, and lots of other security checks. And then for each of the different types of resources, there are specific security checks for those as well. Checking for blob storage, lockdown to virtual network, HTTP access, your core settings not overly permissive. You've got firewalled access and soft delete enabled. Now, sunsetted, in my view, this is AZTS runs on a server and it runs on deployed assets. So AZSK is still providing useful information. So it's still fairly up to date. I mean, it is up to date. It's doing all the security checks that the developer needs to. And one of the great things is it's self-serve. So I can run this locally by using this PowerShell script against my ARM template, which will show issues before I've committed any code, whereas AZTS only shows you problems once they're deployed into an environment. And what you get after the PowerShell template is this. So you get a load of high priority things. You've passed 5 and failed 1. So it's saying, and you've disabled this alert rule. And it's saying, failed Azure SQL database, use AAD admin. So I failed that check on my website.json, which is my ARM template for my Security Essentials project. So all of these I got right, but these I need to do some more work on. So next up is software component analysis. So this is kind of like the NuGet, the packages you're using, whether it's NuGet or npm. There's a couple of options here that I've used. I've used OAuth's dependency check, white source bolt, and debricked, which are all very good and have different pluses and minuses. Also, we can look at Microsoft Secure Code analysis, anti-malware scanner, and BinSkin. So we're going through each of those. So first of all, the OAuth's dependency check. So this is kind of like my go-to. It's pretty thorough and it's pretty easy to install and it's part of the build. It checks for vulnerabilities in the National Vulnerability Database, for instance, cross-site request forgery, cross-site scripting, denial of service, flaws, remote code execution, and buffer overflow. The only problem with it is it can generate a lot of false positives, so it needs manual checking for each of those and maybe an exclusion file. So this is the kind of report you get. So it says project security essentials. This is dependencies. So I've got Azure storage blobs of this version, and there is a medium severity problem with that, but it's of low confidence. So I'm going to need to go and check that. So if I click on one of these, for instance, .NET OpenAuth.OpenID is one of the packages I use. It's saying, well, it's found this evidence that I've got this namespace in here, an assembly name, a product name, and a version. And it's subject to this vulnerability here. So this CVE code. And it says cross-site request forgery vulnerability in OpenID allows remote hackers to restore login session of a user. So that's something I need to look into. Maybe there is a subsequent version, an updated version of this that fixes the problem. More information is usually contained in here. If I think that this doesn't apply to me, then I can just create this suppression file here, which contains the name of this vulnerability. And I can copy that into my project. So here are this is the suppression file I've got so far with all of the ones I think are false positive. And then I've put, so this vulnerability related to AfterLogic MailB, which obviously I don't use. So I said, well, that's not relevant to me. But often they are, and it pulls out a lot of useful information. Great thing about this is that it's self-service, so I can run this locally and also runs as part of the build and can fail the build. And because this landscape is so ever-changing, you know, it can run one day and then fail the next when a new vulnerability is discovered. So next up is the white source bolt, which shows NuGet packages and npm package vulnerabilities. Quite similar, but also covers license risks and compliance. Has free and paid for versions, which include core or extensive language coverage. So basically, same information before, but a lot prettier. And gives you a nice tab within Azure DevOps with that information on. So I've quite liked that one, used that before. Debricked, again, same kind of information, but this feature I really like about it is saying you found a vulnerability. So in version 4.3.0, it's vulnerable, but if you upgrade to 4.3.1, everything's good again. So really, as a developer, it tells you exactly what you need to do. With the other two, it's, well, we can upgrade and hope to fix it, but this one tells you what works. MCSA, an anti-malware check. So for each of the checks so far, they're all great, but I can check in actual malware into my source code, and that will be completely fine. And none of the checks I've done so far will actually pick that up. This runs Windows Defender against my code to make sure there isn't any malware installed on it, but does require a Windows build agent in Azure DevOps to run properly, obviously because it's got Windows Defender on it. Bin skin, so this is kind of if you've got the attack vector of the binaries could be changed in some way. So if you're deploying it to someone's laptop or PC, your code, rather than being a web-based server, it can find outdated compilers and bad signing of the binaries you're using. That's part of the NCSA tool suite. So security unit tests, something everyone should be doing. So here it checks, it just gets the attribute and checks that there is an attribute present an authorized attribute present, and if it doesn't, it will fail the build pretty early. Kind of things you can do with unit tests: check the hashing and encryption work and work reliably. Check email templates contain a phishing warning. Enforce the account creation and password reset process. In Netflix, they hash important code like for the authorization or finance code. So if a developer changes that, it fails that hash and then informs the security team. So they can go in and do an additional check that the logic in there has not changed significantly to create a security vulnerability. And enforce incorrect authentication is applied to controllers. So in that example there. So that the system under test is a controller in this example, and it checks that the authorized attribute is present. And also the roles contains admin. So here's another example. All these are in the code on GitHub that I'll share at the end of the presentation. And it says for each of these web post, put, delete, it checks that you have all HTTP state change and control actions should be decorated with valid 8 anti-forgery tokens. And if it doesn't, it will fail that build. So yeah, it's a pretty excellent check for checking anti-forgery tokens are present. Okay, so we've made our commits. It's been built. We've now got binaries which are publishable. They can be published to an environment, and usually an integration environment where you can perform some security checks against the deployed application itself. So we can perform dynamic scans and also perform security acceptance checks. So a little bit about my deployment code. I've got a couple of PowerShell scripts. So usually these are ARM template plus PowerShell. That's generally how these things work. And pre-deploy, it creates the minimum Azure resources, and then post-deploy locks down the site to Cloudflare IPs, logs the version of OS of the PAS. That came up in a security audit we had once. And these auditors said, well, how can you prove that Azure are actually updating the PAS? So every time we deploy, we log the version so we can then have that proof. And then, sets up the configuration for testing, which for the acceptance tests. So it's parts of dynamic scans. I tend to use OWASP SAP. Now, OWASP SAP is not a replacement for professional pen test. But it can provide lots of useful information and tests against your environment. Lots of stuff that none of the other tests we've done so far can do, like fuzzing, directory traversal, port scanning, attacks to the WebSockets, can perform cross-site request forgery attacks or check for information disclosure, check the HSTS is not set, etc., etc. So this is the third task, and this is run on Ubuntu. So we deploy to, it says it runs after deployment to integration. So there's a number of steps. That does the penetration test, so that runs OWASP SAP. And this hideous bash script then takes the output from ZAP and transform it into something that Azure DevOps can understand. And then builds the OWASP SAP report. Now, here I'm setting OWASP SAP with a context. So say I'm including in the context everything that runs on this URL, Security Essentials. I'm excluding anything that it might refer to, which is not part of my application. I'm giving it a clue and saying that this is built on Microsoft SQL Server. It's got C and JavaScript in it. It's running on Windows and Git, and that reduces the attack time. So it doesn't bother doing testing for PHP vulnerabilities, for instance. This is how I authenticate against it. These are the users I've got set up, and I've got 2 users. So I can attack it as a normal user and then an admin user, and then attack it as a normal user trying to access admin parts of the application. This is how it manages session management. And I just put in, so if I want to do an automated scan, I then put in the URL here and it goes away and it will generate, excuse me, a report. And you get a report like this. So after several minutes, depending on the rules you've used, it first off does spidering, so it goes and enumerates all the URLs it can access, and then tests each of those for these different attacks. So it's saying that there's a proxy server. So I was so was detected or fingerprinted. Yes, I use Cloudflare. It's checked the content security policy here, and it's saying that the style source uses unsafe inline. Yes, the grid component I use does use unsafe inline. Maybe I can think about using a different grid component that doesn't require unsafe inline and therefore increase my security profile. Oh, here's another content security policy flaw. Unsafe inline used for script. Yeah, that's the same thing. It's that grid component. Maybe we should be considering upgrading that component to something else. Cookies without same site attribute, cookies without secure flags, no cache control or pragma set. So these are all things I can be looking at. OWASP provides a lot of useful information, but it's not a replacement for a full pen test. Finally, security acceptance tests. So things you can do here is validate the anti-throttling work. So by throttling, I mean you can't hammer the login page with numerous failed requests, also known as credential stuffing. So check that the HTTP headers are returned, the account logon and reset password process is enforced rigorously, the content security policy and certificate policy violations are logged correctly. A user registering with a pwned password, as in Troy Hunt's website, have I been pwned, will be shown a warning because my Security Essentials project accesses that via URL. So here I've just got a number of acceptance. I've got acceptance tests as part of the project. Let's have a look. So this is spec flow. When I enter registration details with a pwned, vulnerable password, and error is displayed. So I navigate to the website, click register, go to the logon page, enter these values. Here I've entered a value that's extremely poor. And then it says your password is previously found in the data reach. Please choose another. So your password is rubbish. I don't like it. Choose something that's a bit more secure. So if you've not seen spec flow before, each of these is backed by C# code. So they're driven by a web driver and actually interacts with the web page. So you get a web driver, get the base URL, and then force it to navigate to the page and set the home page, which is pretty cool. So here it prevents a brute force login attempt. So I enter rhubarb22 multiple times, and then it shows you've requested this resource too many times in the last 60 seconds. So after, on the fourth attempt within 60 seconds, it will show them an error message, which will massively slow down an attacker who's trying to brute force your website. And this acceptance test proves that that is the case. Okay, so we've got some valuable feedback from our dynamic tests through OWASP app. And we've checked that all our security acceptance tests are passing. We then push it into production or production-like environment. So there's a number of tests we can do here. We're looking for that the application is available. So looking at availability monitoring, which happily comes as part of Azure. And then looking at Microsoft Defender of the Cloud or AZTS, which I mentioned previously. to check that what we thought our secure settings were are actually what has made it into our production environment, and then get feedback through continuous vulnerability scans. I'll be going through each of those three in turn. In terms of CIA, confidentiality, integrity, and availability, Azure has an availability monitoring tool, and you can set up to poll your website from different data centers across the world to make sure it's available, and of course email you if it's not available. So Microsoft used to be called Azure Security Center, but now Microsoft Defender for the Cloud. You can set up security alerts and recommendations for all Azure resources and also the subscription. So it looks at things like secure ports, tells you to remediate vulnerabilities, and it gives you this nice score to tell you how you're going along. And then for each of those, which resources are vulnerable. So kind of things it can test for, stuff that we've seen previously with AZSK. Set the transparent data encryption for SQL, check that you've set auditing on resources, diagnostic logs enabled, causes restricted, data's encrypted in transit, DDoS protections enabled, two factors enabled, storage firewall, all that good stuff, all that good secure as default we should have set as part of our ARM template and set up using PowerShell. Also can test VMs, but an agent needs to be installed on the VMs, whether that's in cloud or on-prem. An alternative that does a lot of the same stuff is AZTS, which I'll come on to. And then, of course, there's database vulnerability scans. So you generally get these once a week, and you set this up in the Microsoft Defender Blade of SQL Azure. And it's saying, oh, there are 5 failing tests as part of your database. It tests that you've classified sensitive data like first name, surname, email address. You've correctly set the database owners. You've set the database firewall. The guest user is disabled. Transparent data encryption is enabled, and you have no orphaned database roles that aren't in use anymore, providing an enhanced attack surface. So AZTS does a lot of the same stuff, but it seems to be that it runs multi-subscription. So it's an application that you can install with an app service and regular checks. And then it then polls your subscription or your resource group, and then emails you templated reports with all of this information, a lot like AZSK. But with AZSK, it's developer-led. You can run it locally, whereas the AZTS is installed in the server against a deployed environment, which in my book's a little too late, but it still can be a useful tool. It does provide some sample secure ARM templates with those settings. This is what it looks like. So it comes up with feedback like monitoring must be enabled, always on, should be configured for app service for availability. HTTPS has not been enforced for this project here. All the kind of same rules that AZSK provided. So a couple of things I've not looked at here. The Azure portal and DevOps using two-factor authentication, because CI/CD is now the heart of your security profile. If a developer excludes the checks, installs some malware and then disables the malware checker and then re-enables that malware checker step, then you've still got some malware deployed somewhere, which is not great for your security profile. So you need auditing on that, and you also need to control who has access and who can change that CI/CD pipeline. Code reviews are really powerful. So your peers, going to your peers and asking them to review your code for security vulnerabilities is a really great way you can learn about secure coding that I've not covered here. Now, pen tests inform your process, and I'll definitely, what we've talked about today is not a replacement for a pen test, but those pen tests should then feed back into that Devsecops process, grabbing all that information and saying, well, what can we do for static analysis that would have picked up the vulnerability that was found during pen testing? How can we change our process? How can we change our code reviews? How can we change dynamic testing? Can we write a security unit test that will pick up this vulnerability in future? Can we write an acceptance test that will pick it up? So pen tests are still an important part, but really you shouldn't be going to the pen tester. Shouldn't be going to, you're running jQuery 1. You can pick that up yourself using a component analysis tool. The pen tests are really for the stuff the automated tools can't tell you about. So in summary, secure defaults means fewer security defects, lower cost, quicker to remediate. Automated deployments means we can fix these things faster. We talked about a number of different steps we can take to improve the security profile of our code. We've talked about lightweight threat modeling, using the Azure template, which is great for identifying secure defaults. The kind of checks we can do as part of our IDE using a number of different plugins. And then for the CI/CD pipelines, static checking using FXCOP, which can pick up a number of different security rules and fail at the build. Sonar Cloud provides great examples on how to create more secure code. AZSK will tell you whether your ARM template is using good secure defaults or not. MCSA will tell you whether you've checked in credentials or not. And the component analysis, you've got a number of different options that do roughly the same thing, from OWASP dependency check or white source bolt or debricked. And then finally bin skim, which checks for insecurely hashed binaries. Then after you've deployed, dynamic testing using OWASP ZAP, and then finally your security acceptance tests. Once it's in production, you've got availability monitoring, Microsoft Defender for what is actually deployed and whether anyone's made any unauthorized changes to it. AZTS provides a similar capability but cross subscription, and then continuous vulnerability scans in the database. So definitely, as I said before, no one tool is a silver bullet. Each has its own specialties and provides really useful information. I've got a couple of resources here, which I think are going to be tweeted out, or you can get these slides, you can pick this up. There's a couple of Pluralsight courses, which I'd highly recommend. The core of the process I've spoken about today is from this book by Jim Bird, Securing Software Through Continuous Delivery, which is an excellent overview of the DevSecOps process. And really, read the docs, the Azure Security Best Practices. This is an excellent, well-written document of everything you should be doing in terms of your Azure security. Okay, so the code. There's a couple of links to the code. Follow me on Twitter, and all of these slides are on SlideShare. Now, if there are any questions, I'll be happy to answer them now.
Yes, hi John. There are a couple of questions, so I'll bring them up on the screen. So we've got one from Daniel. He says, "Hi John, by how much does it reduce time to detect?" I think that was initially when you had just started your presentation.
Yeah, I mean, usually quite a lot, because you can have a vulnerability on your production environment for days, weeks, months, years before it gets exploited. So having all of these steps testing what you're doing as you're going in and developing code can really help you detect your vulnerabilities much faster. Like from when you commit the code, or at least overnight rather than years down the line.
Okay, and then we've got a question from Ali. Best practice to implement the security in the case. An institute closed network, and we would like to be connected to just for some Power BI visualization.
Okay, I mean, you can install Microsoft Defender on your on-prem VMs, and that could do some of those checks for you. And we look at how you can close down vulnerabilities related to your VMs. And then there will be a ZSK or Microsoft Defender for the stuff that's on Azure, if I'm understanding you correctly, the Azure SQL DB. So if that's on Azure, then you'll use all the standard Azure tests and pick up any vulnerabilities related to those.
I think that's all with the questions.
Oh, fantastic. If you have any more questions, then contact me on LinkedIn or Twitter. I'd be more than happy to help out in whatever way I can.
Okay, great. Thank you so much, John. Thanks for an amazing session. And this session will be uploaded on the Reactor YouTube channel. I think it will be available instantly to have so you can go back and listen to it again. But till then, thank you very much. And we'll hope to see you again sometime doing another session for the reactors.
Thank you.